Following on with episode 3, episode 4 is a bit of scattered progress on a whole variety of topics. First one being a little bit more information on this press brake. We've now got it installed. One of the many talents of Rob Roy is that he's also a licensed electrician. So this is a 3-phase machine, and we had to run a little bit of wire from our phase converter on the other side of the shop. But we've given it a really nice home in the back corner. We've got it all functional, and we even tested it on a couple little side projects that we had going on. But we're good to go on that. I'll just take you over to the phase converter and I'll show you what we did, and then we'll run this through a couple cycles. I'm over on the far side of the shop here, and this is an area that doesn't get shown too much except for very specific shots like milling machine projects or lathe projects, but it's really important what's going on over here to the ability of us to be able to put in that press brake, because that's a 3-phase machine. Typhoon Legacy is, to the building here, we only have single-phase 220 power. So we've installed, quite a while ago, for the milling machine specifically, we installed a rotary phase converter. And this is our phase converter panel. You can see the single-phase 220 comes into it. It's got a wire that goes down to the floor here, which is down to that motor. It's a 15 horsepower 3-phase motor, and that basically idles along and generates our third leg for 3-phase power, puts it back into the magical box on the wall, and then it spits out 3-phase power, which enables us to power our milling machine, our brand new press brake over there, and even this key seater that we've got on the side. Now, because I built this system in here specifically for the milling machine, it was only ever wired for that. And thankfully, Rob Roy was able to help me out and get this stuff all wired in. And basically, we put this gutter on here, and now we've got power that goes up. I did a little bit of bruisey work in the attic, crawling on my knees and running the wire over for our press brake. Now we've got 3-phase power to the other side of the shop as well, which is fantastic. And while we were at it, because I had this key seater here, it was kind of an opportunity, one of my many opportunities at auctions. I got a really good deal on it. But it had never been hooked up, and I was actually considering just selling it, because really the only reason I bought it was to put the keyways, or broach the keyways into the roll forming, or the roll dies for the tube scoring. But because we're working here, Rob plugged it all in for us, hooked it all up, and now we've got 3-phase power to this. So all 3 of our 3-phase power machines are hooked up. I'll just let me see, I'll try and get that in there. I'll just turn on the phase converter here. So you've got to start the phase converter. You need the motor on the ground generating that third leg. You give it a few minutes, and then you can only run one piece of equipment at a time, which really isn't a big deal here because I'm typically the only one working on this equipment. The downside is that you have to listen to that motor idling along all the time. So now everything's off, making sure everything's off, and we're not starting more than one piece. Lockout tags, this is brand new, but we're going to be putting lockout tags on those, so only one can be open at the time, or one circuit can be closed at a time. So we'll start off with the key seater because we're standing here. Got power onto that, and essentially this piece of equipment is just replacing a broach in a press. But that's what it does. So this is a 3/4 inch shaft, and it's got a 1/4 inch key, which is exactly what we need for our tube scoring machine. I've got to clean this up a little bit, but it's got an automatic feed, and you can select how many thousandths of an inch you want the feed to have, and the table feeds into the bar. So you'll be able to predetermine the depths that you want your key slot to be, or your keyway to be, and you'll just scrape a few thou at a time until you get there. So nice piece of equipment to have. It'll definitely make it easier to do what we need to do with those tube scoring dies. Definitely overkill, but that's kind of how I roll sometimes. So I'm going to leave this on, our phase converter on. I'm going to shut the power off to the key seater machine. Just do a quick check, verify that nothing's changed. I'm going to turn the power on over to our press brake, and I'll meet you guys over there, and we'll just run it through a couple cycles. So back over the press brake, there's a lot of safety built into this one as well. But we're all powered up and ready to go. I'll just do a couple cycles to show you what's going on with it. Really, it's an amazing machine. We've got a couple of crude upper die in it right now, just bumping over a couple pieces of metal to test it. But what I'm looking at doing is setting up a lower polyurethane female die so that we can get some really nice crisp bends without a lot of expensive tooling. So here we go. So pretty basic. It's adjustable, stroke length is adjustable. But up and down. This one's got 12 tons of force, which is plenty for what we need over that distance, and the gauges of material and alloys of material that we work with in the shop here. So really a nice piece of kit. Pretty simple movements, but very useful for all sorts of stuff around here, and it gives us a lot of capabilities beyond what we could do before. So again, thank you to Pyrotech for their donation. I'm going to find all sorts of new uses for this too. Last episode I mentioned that we're working on the stretch forming dies and getting to the point where we're going to stretch form the frames K and L, which are the transport joint on the Typhoon. And this represents a change from the actual Typhoon's transport joint frames, which were set apart from each other and made out of sheet metal. These are the extrusions here that we're going to be using. And right now, the first step is the tooling design is complete. The next step is that the dies have now been produced by our friends at Dependable Industries in Burnaby. They did a fantastic job. And now the material that we have for doing this process is actually in condition T351, which is essentially the same as T4 or T3, just the process that it gets it there. But it's in its hardened state. It's a 2024 alloy. And it's not in a condition that's ideal for stretch forming. So these will be going over to Pyrotech Aerospace, our sponsor, and our sponsor that generously provided this press brake, and we'll be solution heat treating them, bringing them to either a full anneal or a W condition. We're still determining what we'd like to do there. And then over to Versaform for pulling over the dies that were made by Dependable Industries. So a lot of people in the works here, all of them giving us fantastic prices and generally looking to support the project on its way forward. Before we get this over there, the only extrusion that I could find off the shelf without having a batch done for ourselves that has the correct radius, the correct thickness, has legs, which are these guys. There's two legs on a 90-degree extrusion. It has legs that are too long for the purposes that we have. So I'm going to have to cut these down. But the status of this project right now is we're just doing a bunch of work between designers and Versaform, who's going to be doing the pulling, and making sure that before I cut them down, we verify a couple samples that everything is going to be just right to make sure that they fit on the dies and the process goes smoothly. So that's the update on the stretch form for now. I'll take you over to a bunch of other projects that I've got going. Another area that I'm working on right now, I alluded to in episode 3, and that is the wiring harness for the Merlin. And you can see that we've got our leads. We had these custom built for us because of the length of them to get up to the forward cylinders from the magnetos. They're all ready to go. We've switched the engine over to an automotive style spark plug that's commonly used in Merlins now. It's the correct temperature range, correct reach, correct gap, all of that stuff. So we're quite happy there. But the problem is that we've got a bit of an issue in connecting these leads to the magnetos correctly. So our friends over at the Bomber Command Museum have helped us out. And these are the Packard Merlin caps, magneto caps here. And the Bakelite pieces that we're missing are these guys here. They fit down inside the magneto. So before I get going too far on what I'm doing right here, I'm just going to go back and I'll show you a little bit of video footage on the caps themselves and another issue that we had with those. So with our ignition harnesses, Rob has taken these guys apart. This is the cap that fits over the distributor side of the magnetos on the Merlin. So it'll sit something like that. And the ignition harness ends go inside that block. To do that, they're held in by these plates. As you can see, there's a recess in the back. The ignition wire that would normally be through there comes down, sits in there, and there's a plate with a swaged anchor nut in place there. This sits in the cap, like that, and then that goes in here, and that's where the contact is going to be for the distributor block into the magneto. And what we've got, Rob's cleaned this one up, everything looked pretty good on it. But our other side was a little bit worse for wear, and the plate that we have is missing the inside. And I don't know if somebody picked away at it and broke it, or if corrosion possibly broke that away, but either way we're missing the inside. So I'm going to go ahead and Rob has asked if I'd make a new plate for him. So we'll make a new plate out of aluminum, and we'll replace these swage nuts with anchor nuts. The parts that are sent from the Bomber Command Museum to help us out, there are some subtle differences. We're going to have to do some modifications. But basically, I'm going to show you now the parts that we're going in and we're going to rob out of these harnesses. The harnesses here are actually overhauled harnesses from a Packard Merlin 224. I opened the cap here to show you guys what was inside. And part of that was the actual overhaul tag that was in there. And it says engine type Packard 224. Harness assembly. It's got the part number, job number, and serviceable tag. December 23rd, 1954 is when this particular harness was overhauled. So I'm going to go into it now and show you the parts that I'm going to rob out of it. Now, the first and foremost, all of these bolts in here are locked with tabs. So I'll undo the tabs. The BTH plate for these leads is quite a bit more compact than the Packard unit. So there's going to be some differences there. We're pretty fortunate that these are, the Bakelite components are the same thickness. The general assembly of this is also the same, which is nice. But what I'm going to do now is I'll disconnect the lead ends so I don't cause any damage in here. And I'll show you exactly what goes on inside there. You can probably see there's some little slots in the side of them there. And there's 4 slots, so there's little tabs that are bent around and they've got a lip on them, and they lock into another lip that's on the inside of the Bakelite. So basically what I do is I just give them a little bit of a squeeze. Sometimes I use 2 pairs of pliers, but usually one does it. And then you can pull that off. I'll hold that with the pliers there, but you can see that's the cap that goes in there. You can see the little tiny lip that's on it, and that retains it when it's inside. So I'll put these in a nice pile. The next thing that's in there is the spring, and that keeps tension on the cap, spring loaded so it stays in contact with the inside of the magneto. The spring can just be pulled. I usually give them a little bit of a twist. There's that. Now what you can see inside here is a series of little wires. And basically that's the plug lead, the wires in the end of the plug lead, just like with these guys here. And it's stripped, the wires come out, and they come out through the center of this hole that's in there. And then they're bent over backwards around a little piece of steel. So once they're bent around that piece of steel, then there's a sleeve that's pushed over, and the sleeve holds the wires in place, and the spring goes down on top of the sleeve. So it's all one compact little assembly, but it prevents the wire from being able to be pulled back out. So now what I've got to do is reach in there and just try and get that little sleeve off. There you go. So there's the sleeve. It's just a little, like a hat bushing. So I'll put that to the side. And then I will straighten these wires off, or unbend the wires that hold this in place. So this is the little bushing. It sits in there just like that. And the wires bend down over the outside of it. And then that next bushing gets pressed down on top of the wires over this and really holds it together. And then the spring sits on top of that. Boop. Like that. And then the cap on top of that. So all very important pieces, and in this case they're all in wonderful shape. Now there's this guy. This is the Bakelite component that we're trying to save, and because all of that's out of there, there's no means of retention, so it just slides off of the plug lead. Now this one is one of the Bakelite insulators that came off of our BTH setup, and as you can see, it's got some damage on it. Believe it or not, that's one of the better ones that came out. I think we salvaged, I don't know, half a dozen of them that are potentially usable, all very, very brittle. And this is one that came out of this setup here. So you can see diameter-wise, everything measures out the same. They're built in the same fashion, but there's a couple of length differences on them. The ones off the Packard are essentially a 1/4 inch longer, and it's in two different areas. The one area that we can't do anything about, we can't shorten this, is the front, because it's got that inside lip where the cap is retained. You can just see it there. The back is a little bit longer and sticks out internally. If you can see that, my fat thumb wasn't in the way. But we can trim that down because it's essentially just a tube, and it doesn't have any bearing on it. So we'll knock that down a little bit to make it fit better into the cap, but we're going to have to live with slightly longer insulators in our setup. So that means that our insulators are going to have a spacer put in them. With this O-ring, it's kind of handy for us because you can see the recesses in this plate where these insulators sit. There's the original one from our setup, and it sits almost flush in there, which allows it to, nest in with the backing plate that we made, comme ça, and basically sit flush. Then this setup goes in here, and you got an Uncle Bob. Now, because this is longer, it's going to protrude farther, or is it? With that O-ring, placing this into the same space as the original one, you can see how much higher the Packard setup sits than our Rolls setup. The backing plate's going to sit on there. It still fits. You can see there's a protrusion of that insulator a little bit beyond. We can take that down so it sits flush, but we're going to have to live with a gap in between here. The O-ring's helping us there because essentially it gives us insulators that are even on this side, but uneven on this side. So we're looking at making, because this is a ground running engine, we're looking at making a spacer that will sit in between those two plates and hold it snugly in position. And then that whole assembly will fit inside that housing. It will sit proud as well. Instead of being recessed completely into the housing, it'll only be partially recessed, which will center it. The retaining bolts will be able to snug it down against those O-rings. We'll still get a nice seal. We'll get the proper length in here, and everything should fit quite nicely, albeit we'll have a shoulder on the outside. But we'll have a very good fit and function for contact on our magnetos. Another item on the list of things to do is something I've avoided for a long time, and that's the fenders on the Merlin trailer. So without further ado, I'll start with the inner fender, the aluminum panel there, and we'll start trimming that. So that panel is now roughed out, and it won't be finished until I'm done with this step. This step is to lay out my hole pattern along this inside flange on the fender and install anchor nuts on it so that we can put the fender back on and fit that aluminum plate. So I've determined for the correct fit and access to all the screw heads when it's mounted on the trailer, I'm going to start off with 2 inches above the notched cutout, and then I'm going to do 10 5/8 straight line distance approximately to get a nice even space of all 9 screw locations. So each one of these locations now needs an anchor nut so that you don't have to reach into the back and hold a nut while you're putting the screw in. I happen to have a whole bunch of these corner anchor nuts here, not necessarily required for this application, but they'll work really well. And the important thing with these is that the anchor nut's positioned properly over the hole so the screw falls in, but the alignment of the rivets that hold the nut in place is also important. And to do that, usually you use a drill jig, like one of these guys, and you use that as a pilot pin here, and then you can drill the rivet holes on either side and flip it over and blah, blah, blah. But I don't have one for this particular style of anchor nut. So what I'm going to do is I'm going to take a bolt that fits into that nut. I'm going to thread it in there, cut the head off, and that'll work as my pilot. I can then place this on here and hold the first drilled hole with a cleco and drill the second hole. So it's not quite as nice as having a drill jig, but it works really well and it'll keep all your holes aligned. That is our new drill jig. So first step now will be to drill all the centers out to a number 10, which is a clearance hole for a 3/16 bolt, of which this is one, and we'll go from there for rivet holes. With the bolt holes now drilled and deburred, we can take our drill jig, and although the anchor nuts will sit on this side, we're going to use it on this side, drop it into place, and install a cleco clamp. Where I'd like it to sit. Then we'll grab our number 40 drill bit, which is a clearance hole for a 332 rivet, and drill the first hole. Now normally, I'd just grab any old cleco, kind of like this guy, seasoned veteran, but because it's you guys, I'm going to use a stunt cleco. I grabbed a brand new one. And the cleco now holds that hole in correct alignment. I can pull the cleco clamp and drill that second hole. And just like that, the 3 holes are drilled. I'll carry on and do the rest of them, and then we'll get some riveting done. Now you may have noticed that these anchor nuts are dimpled. You can see that recess in there, and that's to allow for thin materials and countersunk rivets, so it remains flush on the side of the mating part. However, this is actually quite thick material, and that's one of the reasons that I kept these older fenders. So it's going to be a little bit of work, but I'm actually going to dimple this flange so that it nests nicely in there. To dimple this material, I'm just going to use the hand squeeze riveter fitted with a set of dimple dies, 332 dimple dies to be specific, so that our rivets will sit nice and flush. Before I install these anchor nuts, I'm going to take these number 10 holes and I'm going to oversize them to 1/4 inch, and that'll just take care of any kind of misalignment that we might have. There's approximately 6/1000 of an inch oversize right now, and over the length, which is almost 6 feet of this fender, it doesn't allow for any variation or changes to it. So it's either do that now or fight with it and have to remove the anchor nuts after to do it. So I'm going to do it now. The holes are now oversized. We've got good clearance in there for the bolts when we're doing our install. Everything's dimpled and deburred. I also gave a little toot to each one of those dimples with a countersink just to clean out the paint. And there's a little bit of body fill and stuff in there, so I didn't want the rivets sitting on top of that. So that's cleaned out and we're ready to install our friends the anchor nut. So to do this, 1 Cleco in 1 rivet hole. I also take a punch of the appropriate size, in this case it's 332, and I just align the other one. Then I make sure that the nut is centered in the hole, which it is, and I can go ahead and pop a fastener in there. So the first rivet can go in, boop, and it goes down very nicely. Then I get my handy dandy pneumatic squeeze riveter, which I'm using because I like to squeeze the back of the fastener, and it fits inside the fender really nicely. And I just go ahead and I squeeze that rivet. There we go. 1 rivet. Then I pull my Cleco. I install another rivet. And again. One anchor nut. So now that that's in, I'm going to go through and I will move on to each and every one of these and get them all installed. And we'll be able to install the fender again and start fitting up our inner. With all of the holes drilled and the anchor nuts installed, I've now mounted the fender itself to the trailer, clamped it in position so it's not going to move, and this is the position that it's going to sit when it's permanently mounted. I've brought the aluminum plate that we've rough trimmed into place. I've shimmed it so it's nice and level with the top here, and I'll go ahead and use a hole finder to pick up the holes that are underneath and transfer them into this sheet, and that way we know that the aluminum inner fender will fit perfectly when the outer fender is installed. The premise here is that the hole finder has a pilot on it. The pilot goes into the hole that we've drilled in the fender, and then this top portion comes on top and guides us into the center with the drill bit. Just like that. And an important thing to note is that when you drill this, you don't drill all the way through, or you drill into the bushing and destroy your tool. So you drill part way through and then use a backing piece inside so you don't drill all the way through into the anchor nut and wreck it. And with the panel now secured in position, we can go ahead and mark this out and do a final trim on the saw. I'm going to use a different colored pen just to avoid confusion on the lines that are still there. And just trace at an angle so it's recessed below the radius of the fender lip there. So with that plate trimmed, I'm going to fit it back up to the fender, make sure everything's good. I've deburred it a little, but I wasn't going to show you that part of the process. Self-explanatory. Start with a couple and go from there. That fits up really nicely, everything clamped down. The edge is just below the radius where I wanted it, so I think it looks pretty good. There's a couple other small things I want to do, including a joggle down here and some standoffs that are going to go into the frame, but that's going to be done for next episode. This is where I'm going to leave this one. So I hope you enjoyed it, and we'll catch you next time.